In this problem, the center of disk of radius r and mass m, this is the disk. This is the disk. Center of mass m is attached to a spring of spring constant k. Spring constant k. Inside a ring of radius, ring radius is r. So let us take this is a center of the ring O. R is greater than R as shown in the figure. The other end of the spring is attached to the periphery of the ring. Both the ring and the disc are in the same vertical plane. The disc can only roll along the inside periphery of the ring. It can roll inside only without slipping. The spring can only be stretched or compressed along the periphery of the, so like this only it can, periphery of the ring, following the Hooke's law. In equilibrium, now the disc is in equilibrium. The disc is at the bottom of the ring. Assume small displacement. So, a small displacement we did. The disc small displacement. That small displacement, let us take x. Small displacement x of the disc. The time period of the oscillation of center of mass of the disc. Center of mass of the disc is this one. This is the center of mass. So, the center of mass period of oscillation of the disc is written as T by 2 pi by omega. The correct expression for omega is this we have to calculate. So, to understand, let us take this disc here. The disc is here. So, it is moving along the periphery of the ring. This is the ring periphery. This is the ring periphery here. This is the radius of the disc r. This is the radius of the disc. And from the top, this is O, right? This diagram I am drawing, right? So from top of this disc to here, total distance is r. This is r minus small r. So from center to disc, r minus small r. From center to this radius I have taken, which is touching the periphery of the string. See, when we displace this spring, this disc, I have displaced, right? This is the periphery of the. When I displace it through x distance, right? X distance. What are the forces acting? Let us see. When I displace this one, spring is touching the center to the center of this one. So spring immediately, spring force will act in this direction. Spring force formula Kx. This is the restoring force. That's why minus K. Right. Now, when this disc is moved here to x distance, this weight actually works vertically downwards, weight of the disc. And let us resolve this weight. Here it is theta displacement. So here it is also theta displacement. So this is mg cos theta, and in the same direction, mg sin theta. This is also restoring one, right? Due to the gravity, restoring force is mg sin theta. Due to spring, the restoring force is kx. Both forces are acting. Whenever we displace this one, it want to move down. So in opposite direction, frictional force is acting. These are the forces acting on the disk which is displaced. So disk after we leaving it, after displacing, if I leave, so it goes on like this and it comes down like this. So the disk angular acceleration is alpha dash. This alpha dash is angular acceleration of disk. These are the physical quantities relating to the disk which is displaced from the position A to position B. Right. So let us write all the forces, net forces acting downwards. Net force. Next force. What are for this force? Restoring. What are there? Minus kx minus mg sin theta. Right. This is opposite. So these are minus, that I will take as a plus. Frictional force is equal to MA. Force, net force is equal to MA. Net force is equal to MA. This is F is equal. This is the total force acting. Net force. Restoring plus frictional force. Restoring I will cancel it. Okay. I will strike off so that it is annoying. Right. This is the total force acting on the disk. On the disk. Now, when the disk is rotating, rolling, angular torque I have to calculate. So, torque, angular moment of force. So, total torque on disk is equal to moment of inertia of disk and alpha of the disk. Right? That is the formula. What is this formula? This formula is nothing but tau is equal to I alpha formula I have used. Force into perpendicular distance. Right? Now I will take minus common k. Right? This distance x I want. How? See, this we know na. This formula we know. This is x. This is theta. This distance is r minus r. Right. So this distance is equal to r theta. R minus r into theta. Plus, why? Because minus I have taken common. Mg theta. Why? Theta is very, very small. This angle is very small. So theta. And see, frictional force. See, torque of frictional force. Where torque is the frictional force is acting along the axis of rotation. About the axis of rotation, whatever the force is acting, the torque is equal to 0. So torque due to frictional force is 0. So torque due to frictional force is equal to 0. These are the small things. So torque I am not taking here because force into the perpendicular distance. See, what is the formula for the torque? Force into, force is kx, perpendicular distance. See, where is the axis of rotation? Here. This is the axis of rotation. It is rolling the disk. So from the axis of rotation, distance is r. From the axis of rotation, distance is small r. So I will multiply with small r is equal to, right, moment of inertia of a disk. This is another concept here. The disk is here. This is the radius. This is the center of mass. This is the periphery. This is the axis of rotation. This is the axis going through the center of mass. So about center of mass, about y you have to calculate. See here, about this axis, center of mass you have to calculate. So you have to use parallel axis theorem. So moment of inertia about the disk, about the axis passing through the tangent. That formula we know, na? 3 by 2 mr square into angular acceleration of the disk. Be careful about that one. So this is the equation we got. Now what is the question? The question is, see, once again revisit this question. See, time period of oscillation of center of mass of the disk we want. See here, center of mass of the disk. This center of mass of the disk, center of mass angular acceleration about O we have to calculate. Center of mass of the disk about the about its center of mass we have calculated. This is disk alpha, but we want to know the center of the center of mass of the center of mass of the disk about O. So these two, how can we relate? See, what is the formula for tangential acceleration? I will draw this one here. This is all for extra points we have to remember. See what happens. This is the position of the disk. This is O. This distance is r minus r. This is r. This is axis of rotation. About this axis of rotation, the angular, see, this tangential acceleration of the disk is equal to about axis of rotation. What is the formula? A is equal to r, this small r, and this one is rolling down. So this is alpha of d disk. Idu. But center of mass also going here, right? This is center of mass. So this angular tangential acceleration is equal to, this is the axis of rotation for the center of mass, O. From here to here, r is r minus r into center of mass angular acceleration alpha. These two tangential accelerations are same. So tangential acceleration of disk is equal to tangential acceleration of center of mass of the disk. So from this what we got, disk is r into alpha of the disk is equal to r minus r into alpha of the center of mass, right? So this value I will, here you see 1 r will cancel. So I am having k r minus r plus mg theta I have taken common now from these both terms. 3 by 2 m, 1 r is cancelled, r alpha of disk. So in the place of alpha disk into r, I can write, what I write, minus k r minus r plus mg into theta 3 by 2 m. In this place I will write r minus r alpha of the center of mass of the disk about O, right? Now let us simplify. The alpha came na, so here I will alpha is equal to, I will write alpha is equal to minus this 2 by 3 goes here, this 3 by 2 goes here, it becomes 3 by 2. Now bracket start, k r minus r, this one by m into r minus r plus mg by m into r minus r and theta will be there common. So what are the things that get cancelled? R minus R minus R, M will cancel. So we got an equation alpha is equal to minus 2 by 3 bracket start K by M plus M by K by M K by M G by, this is G by R minus R into theta. This is equation 1. Now this equation resembles the SHM. Comparing with SHM equation. What is the SHM equation? Alpha is equal to minus omega square theta. This is the SHM equation. This equation can also be written, actually you might have studied like this: d square theta by dt square is equal to, alpha is d square theta by dt square minus omega square theta. Right? This is another form of same equation. Right? This is alpha is d square theta by dt. So on comparing with the SHM equation 2, in the place of omega square, this point is there. Therefore, omega square is equal to minus came. Minus and minus, we are not, only omega square, 2 by 3 K by M plus G by R minus R. This is omega square. So omega we have to calculate. Omega is equal to under root 2 by 3 K by M plus G by R minus small r. So this is the answer for our question. So elaborately every small point I discussed. That's why it seems very lengthy. No, it's not a lengthy. Within 1 minute you can do it, because all these things you keep in mind and go on calculating the things. Within 3 steps you will get the answer. So the correct answer for this question, correct option is 2 by 3. Right? Once you get 3 by 2 mr square also, you can judge, you can estimate that 2 by 3 will come. So half of the problem within 2 steps. After that you will have a guess and you can answer this from A. But don't guess always. In this options we can have that luxury of guessing. Anyhow, the A is the correct answer.